So our second transformation is a reflection. So a reflection is a transformation that uses a line like a mirror to reflect the figure. And that mirror line is called the line of reflection. So a reflection in line M will map every point P in the plane to a point P prime, so that for each point, one of the following properties is true. So for example, in this first one, P is not on line M, and M would be the perpendicular bisector of the segment P prime. So we're actually equidistant away from that line of reflection. And then if P is on the line, then it just is reflected onto itself. So we have some coordinate rules for reflection. So if I'm taking a point and reflecting it over the x-axis, so for example, this point right down here is at 5, 2, which is a little hard to see. Then if I'm reflecting over the x-axis, it's going to go down here to the bottom, which would be at 5, -2. So if we kind of think about that as x, y, x stays the same and we have a negative y. Now if I choose to reflect that over the y-axis, again, remember we're equidistant over that, so I would have to be over here at -5, 2. So kind of thinking about that as xy, that would be -xy. Now, if I'm reflecting this over the line y equals x, so that's this line right here. If I'm taking this point, which is again at 5, 2, we're now looking at equidistance in the perpendicular direction. So this time, we would be transforming it to yx. So it gets moved to 2, 5. Which is here. And again, those are equidistant in the perpendicular fashion. And then if I'm transforming it over the line y equals -x, we're taking the same point of 5, 2. Again, it has to be perpendicular. So it's actually going to be transformed to -y, -x. So it would be at -2, -5. Is where it would be transformed to in order for these to be congruent. So you can try to do this with these triangles if you'd like on your own to see how those would be reflected. Okay, so now we're going to talk about a glide reflection. So a glide reflection is a transformation that involves a translation followed by a reflection. So every point P would be mapped to a point P double prime by first a translation mapping P to P prime. So we're shifting it up by our vector. And then we're going to be reflecting. So we're reflecting, so a reflection in line K that's parallel to the translation mapping P prime to P double prime. So what we're seeing is we're transforming it up this way. We're translating it up. So the line of reflection, these both have to be parallel. So our translation vector and our line of reflection are both parallel to each other. And then lastly, when we talk about identifying lines of symmetry, a figure will always have a line symmetry when the figure can be mapped onto itself by a reflection in a line. So this line of reflection is a line of symmetry. Such as line M in this figure. So we have this butterfly below, and so if I'm looking at this line right here, this is our line of symmetry. So it maps the right side of the butterfly onto the left side. And then a figure can have more than one line of symmetry. So for example, this hexagon here, I could have a line of symmetry here that would take, if I were to cut it better in half, it would take this side and map it over there. I could have one here, I could have one here. I would be able to have one right through here, through all of these places. So there are multiple lines of symmetry here. I actually have, this would be 1, 2, 3, 4, 5, and 6. So this guy has 6 lines of symmetry.